Shadar, why don't you take a minute to talk about kind of our work to date and some of the studies that we've done and kind of what our focus is.
Sure. So very briefly, in addition to what Mike said about our activity at M4Site, you can see in the slide there, it's called Game Changers. We're looking at, with our singular focus on how to enhance U.S. manufacturing competitiveness. You can think of that as focusing on two things. One is, what are the emerging technologies? What are the game changers? The idea there is, it's not just be enough to invent here, but we should be able to manufacture what we invent. So bridging the gap between science and manufacturing, we connect researchers with practitioners, and we harness their collective wisdom to identify what are those technologies bubbling up that worthwhile paying attention to, shining light on, and transitioning to the next phase. So we actually enhance their manufacturing readiness so we can actually produce them here. So that's on the emerging technologies. An example there being on the tissue engineering, regenerative medicine being one of the reports we did. Likewise, those are the ideas worth scaling. Based on, if it's going to lead to a new product, new process in the next 5 to 10 years, and if it's got a, broad appeal to different sectors and have a potentially high economic impact with the technology. Those are the things we look for. Then on the other side, we also listen to industry folks and the practitioners to see what the key challenges are. So what are the ideas? What are the challenges worth addressing? That's the other side coming from industry. And again, the cross-cutting challenges across different industry sectors within manufacturing. Again, cybersecurity being one example, certainly supply chain challenges across everybody, education and workforce development. So we connect, again, researchers and practitioners, not only through the Leadership Council members, but also through their network. We work with the various professional societies, trade organizations, and so on to do just that and produce timely reports.
Okay. So, by the way, I should have introduced Shadar. He's actually, wears a few hats, but he's the executive director of M4Site. And with that, I think what I'd like to do now is, in this body of work, what we've done, take a step back. From M4Site perspective, and we were looking more forward-thinking, what can we do? Where are there gaps? One of the things that we discussed as far as the executive committee last fall was that there's a lot of people pointing in different directions when it comes to who owns the space related to cybersecurity and manufacturing. So whether it's different government agencies, the private sector not stepping to the plate, OEMs generally do a pretty good job with it, because they have to. It's driven by their business. But really, what we really think, not only is this fraught with risk, but the awareness isn't there. If Target gets hit during Christmas time, everybody knows about it. Manufacturing gets hit, nobody knows about it. And we'll talk in a minute about where we rank when it comes to the degree of threats in the manufacturing community versus some of the other sectors. But when we looked at that, we said, there's an area where we could provide hopefully some guidance in working with both the public and private sector to provide a path potentially to address some of the needs that need to be addressed. And to frame it a little bit more broadly, and sometimes it's as simple as awareness within the supply chain and the smaller players on how risks manifest themselves. My mother calls me up one day and says, and this didn't really happen, but I met somebody in the grocery store and they said they were involved in business X, so I gave them your email. And so, in comes the email, and it could be from a malicious source. And if I'm a player in the supply chain that doesn't have systems integrated to protect me, boom, there's exposure there. There's all kinds of ways that, if you think about the amount of data that's generated in manufacturing, both on the operational physical side, in how it controls physical equipment, as well as systems, the virtual world. It's daunting. So one of the ways what we decided to do is to reach out with a really what we think is a great partner, particularly suited well to look at it from a technology perspective, that side of the house, and that's the Computing Community Consortium. So Ann Drobnis is on the end she's the director of the CCC. And Ann, why don't you speak about it from your perspective?
As Mike said, I'm Ann Drobnis. I'm the director of the Computing Community Consortium. And first off, I just want to thank everyone for being here, thank the caucus for inviting us, and especially thank M Foresight for including us in this really important work. So just to give you a bit of framing about the CCC, we are a community-based organization. We've been in existence now for 11 years. We are funded by the National Science Foundation to help catalyze and enable exciting, impactful computer science research. So I don't have an actual membership. My membership is the computing research community at large, primarily academics, but we also work a whole lot with industrial research labs as well. But again, research being the focus. And we really want to look forward, not looking back at what's happened, but what can happen. Because the worst thing to happen in this broad research ecosystem would be for funding agencies, policy agencies to create new programs and researchers not be prepared to do the exciting work, or researchers wanting to be doing really cool stuff, but there not be a program to match their needs. So that's where we come together in this broad community, whether it be from the policy agencies, from the researchers themselves. We take in proposals to do workshops, white papers, get people engaged and involved on new topics that then is about research 3-5 years out down the road. Sridhar came to us and said, we know that there's a big problem in cybersecurity and manufacturing, and we know CS researchers are talking about some of these problems, maybe not with respect to the manufacturing space, but let's bring everyone together to see if we can make the synergies happen and learn new lessons and see where we can take the field. So that's the partnership we've been doing, working with here. The other thing that we do, so we take in proposals from the community to help create new programs going forward, but we don't just get people together and have great ideas. We then really work strongly to communicate that information back, whether it's through white papers, reports, briefings, our blog. It's a full circle. It's not just get people together, have the exciting conversations. It's then communicate that information back to the community. And we also are a community building organization. So we have leadership opportunities for early career researchers, teaching people in the research field about how policy works and how that's impactful for them and how they can have an impact, because a lot of computer science researchers don't realize the role that DC actually plays. They just think they write proposals and they get money. And it's important for them to realize they're part of the ecosystem as well and keeping people informed. So that's the background on the CCC. Some of the stuff that we've worked on. So yes, cybersecurity for manufacturers is something we're engaged in right now. But to give you an idea of our breadth, in the past 6 months, we have run workshops on smart and pervasive health, artificial intelligence for social good, nanotechnology information processing systems, cybersocial learning systems, and we are about to release a series of white papers on intelligent infrastructure. That is both an overview on infrastructure and the importance for it to be intelligent as we help rebuild and redesign, but also within all of the domains, ranging from healthcare, transportation, agriculture. I'm missing a few. I know I'm missing quite a few because there are 8 papers, but those should be coming out anytime soon. So we really do work in a variety of areas to help promote research in the field.
Okay, thanks, Ann. So on our panel today, you know who Sridhar and Ann are, but also we have Kevin Fu, who is the professor of electrical engineering and computer science at the University of Michigan, and Bob Frazier. He's cybersecurity chief architect with Lockheed Martin Corporation. I didn't say who I was, but Mike Russo, one hat is the chair of the executive committee from M Foresight, but the other hat is Global Foundries. And I'll just take a second to say who that is, because that's not unlike Lockheed Martin, you probably don't know. And we're not a retail brand, but we're the nation's largest contract semiconductor chip producer. We're second largest in the world. Actually, Lockheed is a customer of ours. I can say that much, can't say anything more. But we do a lot of work for the Department of Defense. We have a couple of trusted foundries. We acquired IBM's microelectronics division, and you could kind of fill in the blanks from there. So we're kind of in a unique position, I think, with starting with Ann from the CCC, going all the way on down to be able to speak to this today. And we also have Kirk McConnell with us today from the Senate Armed Services Committee. So there's the policy maker side, I think, to really round out the panel. So talking about the process, I had mentioned the kind of workshop, or the workshop that we hosted here a few weeks ago. But, and I spoke about how we arrived at the conclusion that this was a space that we could provide some value in. The workshop itself, you can see it's just framing out. I'm not going to read it, but there was a great cross section there. It was actually held on the day of the winter storm, and the way we addressed that was everybody flew in the night before from out of town. The in-towners, we actually bumped out the hotel rooms so we could have a little bit of a pajama party, and we ended up having a pretty good crowd. We were actually more worried about the locals than we were about the folks that were from out of town, and we really looked at it from a couple of perspectives. First of all, how do we manage risk? How do we define risk and manage risk today? And again, there's government people in the room, agencies, industry experts, and academia. And then what are, trying to identify the priorities. If we were going to put together a national effort to address these, what would those priorities be? And what are the gaps? Where are there existing gaps, and where are there existing resources and bodies of work that we could actually build upon and scale? Understand that this is the first step in an ongoing dialogue. It's not like the report's going to come out, it's the playbook, we can all pick up a copy and we'll know how to address cybersecurity. No, it's the beginning of the discussion. We did talk in detail on several related topics. First of all, if you would break it down, system level security and cyber resilience. How do we identify and then recover from potential cyber attacks? The integrity of manufacturing goods from design to the factory floor, looking at where risks and threats could be inserted into the process. How do we identify that and address those? Machine-to-machine security, again, that's the more physical part of cybersecurity. When you think about it, one supplier or one component or one piece of a manufacturing environment might be seen as secure, and another supplier or another piece of the factory floor might be seen as secure. But when you put them together, it just doesn't mean that everything is secure, right? You need to look at it more holistically and where threats can be introduced. And also securely connecting that factory to the supply chain. A lot of risks exist within those small and medium-sized enterprises, as I mentioned earlier, and so trying to get a handle around what those risks might be and how better to not only identify them but address them. And then the cyber intelligence piece: how do we gather information, assess it and share it? And it might sound simple for those of you that haven't lived in a manufacturing environment. We're not inclined to talk about what we do about cyber threats, and we're not inclined to talk about when we've been breached or when we are seeing an existing threat. That all happens. We don't talk about that, but we need to kind of come out of the dark shadows on that and figure out ways that we can share that information in a safe way, so we can learn from and be as good as we can be here as far as a manufacturing community. So if we were to look at kind of some of the key, if we were to bucket some of what came out of that first workshop, really there were some key takeaways, general buckets. First of all, from an R&D challenge perspective and opportunities, there are tools and test beds for assessments, validation, verification, and threat prevention. We're going to talk about in a little while about in ways that we can maybe pool our resources to test and trial and validate various tools, setting up test beds, cyber test beds, if you will. That there was several of the discussions kind of found their way into that area as a potential. Also, from a technology implementation across the supply chain, really looking at better and more effective ways to implement, communicate, and collaborate, and also engage workforce in that process. And then lastly, there were general policy considerations, guidelines and standards and certifications. And there's bits and pieces of that scattered throughout the country and in various organizations that are doing components of that. But we need to really pull that together and develop a national playbook, if you will. So those are just the buckets in general. And just starting off really with the manufacturing risks and what some of the key observations are. And you'll note that I and the team are not being overly prescriptive, because this was when we first, we are just entering into this discussion and what will be an ongoing dialogue. This goes to what I was mentioning earlier. A lot of people don't realize, if you look at the chart on the top, it might be hard to read, but manufacturers receive the greatest volume of targeted cyber attacks across all industries. If you look at 2014 data, 20%. Again, you don't know about it, but think about that. It's not going to get better, because if you look at the interconnectivity, the Internet of Things, et cetera, it's going to get worse over time. So to me, that speaks volumes for why we're even talking about this today. Secondly, threats to operational technology, and we'll talk about what that is in a minute, and industrial control systems unique to the manufacturing sector really demand serious attention. If you think about operational technology, that's the physical piece of what we do. There's the virtual components, and then there's the physical components. So the physical machines and tools, et cetera, within a manufacturing environment, they're fraught with potential risks and ways that you can insert malicious, whether it be attacks, regardless of the form that they take. And then there's the virtual components. That's the technology piece. That's external to the actual physical machine. Also, if you think about every manufacturing job, think of the data that goes into producing something, and think of all the contributors throughout a supply chain that contribute to that process. And every one of those really introduce new risks within the supply chain. So think about systems and think about legacy systems, new systems, the creation of systems, troubleshooting of existing systems, adding different jobs within systems. Every one of those potentially create vulnerabilities. And then maximizing interoperability across the entire supply chain is a high priority for OEMs and creates ecosystem-wide vulnerabilities to cyber threats. So the way we get better as businesses is interoperability, and every time we try to maximize that, there's more risks. And lastly, the lack of security integration across the supply chain, and SMEs in particular, is really proving to weaken the entire system. The chain is only as strong as its weakest link, if you think about that. And you find that OEMs generally do a better job, but they don't share best practices for the reasons that were stated throughout their supply chain. So that's kind of in a nutshell. It's kind of a reality check, if you will. So on the R&D challenges, Kevin, maybe you could take the lead in kind of talking about R&D challenges from your perspective. We really need to better leverage technology in the fight, so why don't I turn it over to you?
Sure. I'm an interloper here. I'm the resident hacker that can't use the audio system. Just so I get a better idea, how many people are representing USG in the audience? Okay, and think tanks? Yeah. Okay, all right. Hackers? Well, they're usually in the back. Yeah. Okay. Okay, so that gives me an idea of what's going on here. So I want to tell you a little bit about what went on in our workshop where I participated in some of the R&D challenges that were identified. Just to give you an idea of my perspective, I come more from the computing side of the world, the virtual world, the bits and the bytes, rather than the kinetic kinds of objects. But if you want afterwards, I can teach you how to induce fatal algorithms and pacemakers if you want to learn more. But anyhow, one of the big problems that was identified in the workshop was really the lack of testability for security. I often get questions like, how much security is enough? Or what's a good metric for security? And pretty much nobody has a good answer. In my field, we call this a badnessometer. It's a scientific term for just how bad things are. And it goes from really, really bad to I don't know. That's pretty much the state of the art of metrics, although folks at NIST are actually working on things that are, I think, much better. But the problem is we don't have a good way to test at scale, at the system scale. And so some of the things we heard at the workshop were, for instance, some of the companies participating are actually standing up their own complete factories just for cybersecurity testing. In other words, a fake factory, just to be able to test at the system level. How do things fall out? Today, I think manufacturers are very good at testing components. You can look at the tensile strength of the metal, you can tear it, you can start to interpolate. But when it comes to integrating components, whether it be an automobile, a drone, or a factory, we really don't have a very good understanding there. And so I think there's a really good question on just what is the role of the federal government in what some feel is a sort of a public good. How do we help all the different industries come together with sophisticated test beds that go beyond just their product? On the validation and verification, that goes hand in hand with security metrics. Again, in the C-suites, you often hear, something gets in the headlines about a security problem, and you'll hear, somebody ask the CISO, the Chief Information Security Officer, will get a question from the board. They might say, hey, our competitor had this happen, their pacemaker got hacked, or their hospital went down for 5 days. Can that happen here? And they have these very binary, sorry for the computer language, they have these very yes/no questions. And the problem is it's really more of a grayscale. It's really there's more subtlety to it. And so to do that verification and validation of the cybersecurity properties of these very sophisticated systems, I believe, as Mike mentioned earlier, it goes by the acronym OT, or doesn't stand for overtime, but basically it's the analogy to IT. So IT, information technologies, things that go boom, things that are kinetic, things that could punch you in the face as opposed to just cause bits and bytes to move, things on the factory floor. When you worry about cybersecurity, how do you verify and validate that? The science is still beginning. We have a lot of understanding at some of the sort of mathematics layers. We have a lot of understanding at, I think, mechanical engineering layers, but there's really, I think, a lack of understanding, a big gap for R&D when it comes to integrating at the system level, when you bring together computing, mechanical engineering, all these different disciplines. Threat prevention. Right now, I would say we're in that awkward phase of, okay, so we're screwed. We forgot to build in security. Okay, it happened. So at the moment, there's a lot of attention to bolting on security after the fact because you've already released a product to the market. What do you do now? Really, manufacturing has to move more toward building in security by design. That's a lot harder. It's a hard pill to swallow because let me give you an example from medical device manufacturing. You typically want to do that when the engineers are still working on the whiteboard. If you've already written any code, if you've already deployed a product, it's kind of too late, and that's what we call legacy. And then you're going to live with that legacy for 3 or 4 decades. And hopefully your adversary will not have hopefully your legacy will not be worse than your adversary's legacy, and maybe you'll be okay. But it's really important to build it in the manufacturing processes. And again, the system level is really going to be key here. But I'd be glad to go into more detail later, maybe during the Q&A period. But I think the high-level problem is cybersecurity is a very interdisciplinary problem. And like anything interdisciplinary, whether it be policy or engineering, it falls through the cracks. You get diffusion of responsibility. It's not clear who owns it, and that's why it's really hard to solve.
All right. Thanks, Kevin. So when we look at technology implementation as related to supply chain, there's a lot of challenges. Companies don't like to share what they're doing to mitigate risks, or when they're exposed or breached. So that's another challenge that we have to overcome. And I think, Bob, from your perspective, why don't you walk us through this slide? I think that you're in a kind of the bird's eye seat when it comes to this.
So I'm the chief security architect at Lockheed Martin, and we're moving toward the factories of the future and digitization, so that you have a lot of manufacturing that's being done by digital machines. And the impetus is to be able to share that data, because when you've got a very expensive equipment costing millions of dollars that are making very specialized parts, and you have a backlog in one factory, you want to be able to, and you have another similar machine in another factory in another part of the country, that you want to try to utilize, you have to be able to ship that information to them. Those three-dimensional models, those bills of materials, all the supply chain information, and you want to be able to leverage those. So if you think of it in terms of if you wanted to print a document and you go and there's a printer that's occupied and you just have to sit and wait until it's empty, or could you print that document at the printer down the hall? It's the same principle, only now it's like pipe bending from a factory in, say, Colorado to one in Florida. And you want to be able to do that in order to be efficient in your manufacturing, to be cost effective, to reduce the cost of your products to your customers, which in Lockheed's case is most of the U.S. government. But it also goes down into the supply chain, who make all the different parts that come into the products that we make. So we're trying to integrate that further, but you have the same type of issues, is like, how do you transfer those files? How do you have that interoperability so in such a way that it's safe and secure? Previously, in architectural models, you would have things where you could make a nice, simple architecture where everything's nice and contained. Well, that's going away now. Now we have so much more interoperability that our interactions in the future are going to look less like hallways in a building where you can control the access, and more to highways where you have everybody driving on there. And you'll have to look at how you're going to regulate it. It's going to be more like, registering cars. Are the cars safe? Are the drivers been trained? Do you have rules about behavior, speed limits, whether you've been drinking and things like that? That's going to take place in the manufacturing sector. And that's where we're going to be moving forward. But there's all these challenges that we have to deal with in that respect. Let's do that real quick. So one of the ways we're dealing with that is starting to build consortiums with other manufacturers. One thing in the security industry that you find is, when manufacturing, at least, and people who produce products, is they don't compete on security. So Lockheed Martin is not going to compete with Boeing on security. We may compete on products, on airplanes, who's got the best airplane. But if they have a security problem, that security problem is going to affect us. The same thing if you're General Electric, if you're GM, Johnson & Johnson, you name it. So a lot of us are starting to compare notes on that and to develop common architectures, what we call reference architectures, where we can say, if you're going to do this type of manufacturing process, here's a way that we've been successful in securing it, and then we get greater adoption. Or we are able to look at it and say, yeah, we've done something similar, but we found it's more efficient to do it this way. And that cross-pollination is helping across the industry. But it's only in its infancy now, and we need a lot more emphasis on that coming forward and sharing that kind of information, sharing information about vulnerabilities, about breaches, and being able to, leverage each other's knowledge and experience, so that we're not all having to learn the same thing at the same time, one at a time. So really, that's where we're at in terms of on the manufacturing side.
Okay, thanks, Bob. If we were to look at really what we need to be doing and how we need to shift is really a collaborative practices and move from a culture where we don't talk about this and don't interact to having a common platform to address the risks. So if you look at this slide, we have internal and external collaborative practices. So talking about business and risks, talking about the types of technologies that we employ, our people and organizational practices and trainings and processes, and then having those aligned and interoperable practices on information security, data security, and cybersecurity. It's really a change in culture where we openly talk about best practices and how to really address threats, how we encounter threats, how we address them. So from a policy consideration, the guideline standard certification, defining a base level of security or software and hardware, products and processes. So if we were to provide the foundation of the house that was easily accessible and understood across the manufacturing community, what would it be? What would that playbook look like? And how can we best share those practices? From a cybersecurity certification, similar to some of the ISO standards, ISO 9001 quality systems, et cetera, offer competitive advantages to hardware. The next bullet really talks about national cybersecurity certification as a potential. How can we offer something across the supply chain? You tend to see the main OEMs are really kind of groundbreakers here, checking the boxes that need to check. But what they sometimes don't realize, and what we don't address, are the suppliers to those OEMs. So maybe having a consistent certification so we can ensure supply chain integrity across the piece makes sense, similar to an underwriter's laboratory. And then really looking at it from overall guidelines and standards on both IT and OT interfaces, making sure that we can authenticate and protect ourselves from different types of attacks, and how do we report and share data on those attacks. We have to come out of the shadows. That we're currently in an environment where we don't necessarily like to talk about that. And from a supplier perspective, you think if I let people know that I've been breached, it could have financial consequences. So there's definitely a shift in the way we think about things is very, very necessary. And I would argue that either we get there on our own or we're going to be forced to get there. And the latter is not really the best approach. And I think we're butting up against that right now. And emerging existing standards and certifications to reduce the overall burden of manufacturers. So right now, especially if you're a smaller player, you go out there and you shop around and you try to find out, how can I be the best I can be? Where do I go? What type of certification? Who can offer me the training? That, in our country, that should not be, we shouldn't have to hunt and peck, if you will, right? We can absolutely be better at that. And then if you really think about it, our cyber certifications should be like the qualifications certifications of the 90s. That's where we are today, and it shouldn't be that you're afraid to talk about it, but in fact, we should set up a national program to help those, especially that don't really have the wherewithal. If you're a smaller supplier, somebody that's further on down the supply chain, you're just trying to keep your lights on. Right? There's no reason why we shouldn't be able to bring to bear our collective strength to really provide more integrity to our supply chain. On potential next steps, I don't want to fully jump our report, which is not out yet. And when we talked about this, there's some things that came out of the discussion, and several of you in the room were there during the discussion. So this is not going to be, this is going to look familiar to you. But we do see some themes that have come out of our first workshop. So forming an information security advisory council for anonymous fault-free sharing of incidents, threats, best practices, and solutions. The first step is really being able to go somewhere to talk about what you've experienced in a safe way, and have that entity be able to, from that, boil from it the learnings and disseminate that through the supply chain in a safe way that doesn't put an individual business at risk, and apply system-wide methodologies. So as there's some OEMs that are doing really great work, and up until now they may have even argued, look, that's a competitive advantage. We have to get beyond that, and in order for us to succeed as a nation, to succeed as a holistic supply chain, we need to be able to be willing to share those best practices. And then developing providing an incentive for a national quality assurance program, so cybersecurity certification or some type of automated tools that we encourage people to use. It's really a shift in the paradigm. So what should we and could we be offering in that regard? And facilitating industry test beds for safe prototype and tests for both IT and OT technologies. Do we set up a lab, or we have the manufacturing institutes, for example? Do we pull a component of that and kind of embed it in every one of those institutes? There's various approaches. And we don't want to be overly prescriptive here, but the idea is how can we improve? And then facilitating the solutions that really no one company or one entity can address on their own. And so merge standards, develop that reference architecture, et cetera. So I think with that, we will open it to some questions and dialogue. And go ahead, Shadar.
I guess Kirk may have to leave, so you want to give him a chance to give it a
Sure.
perspective.
Actually, Kirk is from the Senate Armed Services Committee, and I think has a unique perspective here in how this all kind of rolls up into the security of the nation perspective. So, Kirk, you want to?
Well, I'll try to provide some brief comments. When Sridhar asked me to do this, I'm always puzzled and a little reluctant. It's, you know, you're the congressional representative, and that's a little like asking the UN ambassador from Nigeria to say, "What's the world thinking?" It's not really. I can talk about, you know, one staffer's view from one side of one committee in one house of the Congress. So for what that's worth, as it turns out, this intersection of cybersecurity and manufacturing is something that's pertinent to the Armed Services Committee. You know, in contrast to most government agencies, the Department of Defense is engaged in designing and developing technologies and manufacturing them, and obviously Lockheed Martin is a leading example of that. So we do have you know, manufacturing is a huge aspect of national security. And we have lately been seeing further the impact of cybersecurity concerns on the second and third tier suppliers, all those smaller companies below the level of the Lockheed Martins. The Defense Department imposed a defense federal acquisition regulation, a DFAR, late last year, I guess it was. And this sets up some requirements or mandates requirements for companies to meet with regard to protecting, quote, DoD information. And that flows right through the full supply chains. It flows first to the OEMs, and then they flow it down to their subs, who then flows it down to their smaller providers. And it's one thing, you know, after working at this for years, big companies like Lockheed Martin and the Boeings and Northrop Grummans, of course, are getting a handle on securing their enterprises. But it's when you start to get down to the second and third tiers that things look very different. As people have already pointed out, their margins are so small, and all of a sudden now there's this requirement to be able to prove that you're adequately segregating DoD information and processes and protecting them in a certain way. And these companies can't afford this, and they can't afford to do it in the time scale that DoD seems to have allowed for this. So we're getting a parade of small companies come through the committee seeking relief, and they're actually telling us, you know, at some point the F-35 the production is going to stop because we can't certify that we're meeting these new requirements, and we're not going to be able to deliver parts, and then eventually that works its way up, and Lockheed can't deliver product. A small slam on the OEMs here. The OEMs are not the ones complaining so much about this DFAR, because I think they feel that they can meet the requirements, and the smaller companies are asking the big companies for help, and the big companies say, "Sure, we'll be glad to sell you our cybersecurity services," and the little companies can't afford that. So this is something that is happening now. You know, this is occasioned by the Defense Department leadership and Congress watching, airplanes that look a lot like the F-35 being flown in China, and we've all read those stories. Designs and plans and technology, intellectual properties being stolen from our defense industrial base and is being used by our potential adversaries. So this is a huge problem. And as everyone here knows, the Internet of Things, digital manufacturing, all of this is just making it so much so much harder to do. Sridhar had asked if I would provide some sort of speculation about what Congress might be thinking about this. As you might imagine, with what's been in the news for the last 6 months or so about Russia conducting information operations through cyberspace to hack the election, that's dominating everyone's minds right now. But while this operation took place in the sort of the cognitive sphere, in other words, it dealt with content and not so much the technical aspects of breaking into networks and stealing intellectual property or subverting supply chains. Nonetheless, this is the kind of event that can have a galvanizing effect on the country. I don't know if it's gonna lead to that, but certainly this has sharpened, in my sense, sharpened at least the members of the Armed Services Committee's minds about sort of enough is enough with regard to cybersecurity and the need for us to both take some new actions and think new thoughts, as well as to build a deterrence capability. I think it's way too early to say what shape or form I think this might take policy-wise, but we have a new administration, and that always is accompanied by people deciding to do some fresh thinking and open to some new ideas. I have a hunch that what people are thinking is that we're really going to have to do better at whole of government integration. That the Defense Department has one piece of the defense of cyber defense problem. Law enforcement has a big piece. Homeland Security does, and of course the private sector, especially critical infrastructure. And I think that what I'm kind of hearing is that we have to find new mechanisms for integrating and achieving collaborative interoperability, if you will, at both the level of strategic planning and strategy development, as well as operationally in terms of response. It always comes up about critical infrastructure, including critical manufacturing infrastructure. Do we regulate? Does the government end up trying to regulate that? That proved to be just a non-starter. As you all will remember, several years ago when the Lieberman-Collins bill was out, and there was a big fights about even suggesting that we go down that road. I don't think politically that's feasible, even if somebody wanted to do that. At the same time, the country is essentially then asking the private sector to spend large amounts of money and brain power defending against nation-state level threats. I mean, and it's kind of crazy on its face, right? We don't ask General Electric to build a missile defense system to shoot down ballistic missiles, but we're asking them industry to do the equivalent of shooting down malicious packets. So how do you get around that? Well, this is just absolutely personal opinion, but I think we're going to have to get to a place where the government just pays for some absolutely necessary security features in especially at least the most critical nodes of the most critical portions of infrastructure. I don't know that anybody's ready to go there, but it's certainly something that I'm going to be recommending to people that we start thinking about. I love the comments about the institutes maybe being a test bed for cybersecurity. I mean, they are tasked with achieving manufacturing readiness levels of new technologies, and why shouldn't cybersecurity be kind of baked into that? Maybe even that's something the government could provide some money for them to undertake. I also love the kind of the idea of thinking about NIST. You know, NIST put out this great framework for cybersecurity for sort of, you know, organizations and enterprises as a whole. But is there something that they could be doing specifically tailored to the manufacturing sector? I think that's an interesting idea too. Anyway, I'll leave it at that.
Yeah, so thanks, Kurt. I think your clock is ticking, but before, I think, did you have to leave at 2? Before you do, I want to gauge a little, you have a couple minutes?
Let's put it this way, I have to get to Fort Meade by 3, so that's my problem.
Okay.
But I'm late to everything, so.
All right, I think that was a green light to engage you a little bit further then, I think. Everybody heard that. I heard green light, right? So, yeah, you're outnumbered, Kurt.
Yeah.
I would just add a little bit that one of the things that critical infrastructure struggles with is technical debt. And by technical debt, I mean you've got old systems that are working perfectly well. They're making money, they're providing electricity, they're manufacturing equipment, they're producing products. To go in and to try to change those to make them more resistant to cyber attacks is very expensive, and it would take things offline. So we have to start looking for other ways to get around that, other mitigating defenses we can. At the same time, going out to the companies that make these machines and say, you know, do something that is a little more modular. If when you build your control system is part of the actual system, you've kind of handicapped yourself. If you look at point of sale systems and cash registers that existed, say, 15, 20 years ago versus people running their businesses off of an iPad, which is completely interchangeable. Perhaps that's a better model for controllers in the future as we move forward. But these are the sorts of things that we need to do, as Kevin and Dr. Fu said, we need to do this at the whiteboard. We need to get that done before we start putting the software and doing any of that kind of planning.
Yeah, and just to make it a little more concrete, I just came back from a device manufacturer who still ships analysis. It's for analyzing infectious diseases at hospitals. They still ship Windows 3.1.1 on their medical devices. Just to put that in context, that's back when our mice had little rubber balls on the inside. And that's how old and how much malware, 20, 30 years of malware can still break into these things.
Yeah, so maybe a good way to kick off a broader discussion is before, Kirk, you actually have to leave. Don't want you to be late, but if you think about the direction that the Armed Services Committee is moving in from a defense perspective, which fortunately and unfortunately doesn't drive the entire supply chain, right? So there's challenges associated with that. For those small players that their entire product line services the Department of Defense, it's one thing, but for the broader manufacturing community that it's a small percentage of their business, if we don't do this right, there's other risks, right? So if you think about it from the perspective of not wanting to do something that actually hurts the ability to procure parts and systems that DoD needs. And if you think about some of what manufacturers deal with, right? Difficulty to implement and validate security on operations that are always running. Manufacturers that just won't shut down what's still working. They have to retrofit legacy operations, physical operations with high risk profiles, safety, environment, and cost. Physical facilities in a supply chain in which physical product and materials, energy, and data move through them all the time. And then a high diversity of operational systems and proprietary data that systems require. If you figure how manufacturers, commercial manufacturers have to manage all that. They can't stop. They can't segregate. They have to keep their lines running. And if you think about the overall needs of the Armed Services Committee, what do you think? And maybe I'm not asking you if you had the answer, maybe you wouldn't be sitting here today, right? But from your perspective, is there an opportunity for a collaboration, maybe exactly the path we're moving down right now, to bring in the commercial industry to have a discussion on what will work and how should we make it work to move forward? Do you have any thoughts on that? I mean, there's kind of a disconnect right now, right, on what is needed by the Defense Department and increasingly so, and what commercial business can do to, at least what they think they need to do versus what they actually have to do. I would argue they're going to have to get there anyway, to some degree.
Yeah, I tell you, I'm certainly not smart enough to answer that question. I mean, it's really obviously very hard. I think that the department has to be able to be flexible in this. I mean, I understand, it's a big organization. They have, they put out policy, but and it's not known for its flexibility and agility. But I think somehow in this case, we really need to get there, or you're going to lose. You're going to have bad impacts to your industrial base and your ability to make things in the near term. You talk about enterprises, not being able to stop while they do security upgrades, but part of what's happening here is that we're interjecting technologies into the manufacturing enterprises, and it's those technologies that are introducing security problems. So, clearly it's happening in industry that we are incrementally making changes to the enterprise while it's still running for enhanced capabilities and productivity. We need to be injecting those same kinds of processes on an incremental basis for security. I just think that in the end, companies that have valuable intellectual property or they're running dangerous processes, I mean, there's no way around this. It's not just meeting the need like the government says, you got to protect my property, but it's for your own, if it's for their own good. It's for their own safety of their enterprise, and it's for the safety and security of their own intellectual property. That I think we have to figure out ways to do this. And maybe technology helps. We had Pacific Northwest National Lab come in and see us a couple of weeks ago, and there's a team of folks out there saying, hey, 3D printing, look, I could print a circuit board like on demand that can replicate what my programmable logic device does, right? So now maybe I don't have to have this vulnerable programmable control device in my process. I have a 3D printed circuit board, right? And I can modify them at will. I mean, this just is an example of ways that we could maybe think about overcoming these security problems.
And I think I would add that cuts down on the costs.
Yeah.
So we have an incentive to do this, to save money, to produce cheaper products. And, being able to have that kind of agility where you can print a circuit board, or if you're a supplier, say, hey, I print circuit boards better than anybody. Everybody send me your files securely to me, and I'll make them and guarantee the integrity and send them back. That could create an economy of scale that could save lots of money on manufactured products. So that is a critical mass we need to cultivate to get moving, to start moving some of these problems forward, and taking obsolete things with the Windows 3.1 out to something that's running off of a phone or an iPad that can do the same thing but do it better, cheaper, faster.
To add, it's a great example. It also adds vulnerabilities to introduce, intentionally errors in the circuit board.
I'm sorry, introduce what?
For somebody to break in and change the design so little that it can hurt the final product.
Yeah,
too.
cause something terrible to
So-
happen.
Right, there's that opposite and equal reaction when you introduce new technology. Usually, every time you introduce a new technology, it introduces the number of risks that are equal to the problem you just solved with the new technology. So that's going back to Kevin's whiteboard, anticipating what those problems are and starting the solving process prior to the actual deployment.
Okay, so we have additional time for questions, so we actually have the room for a total of 2 hours. So first of all, thanks to the House Manufacturing Caucus for what we think would be an ongoing partnership, should be an ongoing partnership. You should all see us as at your disposal. We're here for both the public and private sector to provide guidance in areas that are important to manufacturing, especially focused on, from a technology perspective, how we can employ and deploy technologies that are important to the manufacturing base. But so hopefully this is the beginning of an ongoing relationship. But we're not going to end here. If people want to stick around and continue the dialogue, some of us have to go. And thanks very much. Appreciate it. Some of us have day jobs, right? So we can't sit around here all day. So we're going to make ourselves available here for another 45 minutes if you want to carry on the discussion.
One last comment. I want to point out that, speaking of day jobs, and we have incredible folks on our leadership council, and includes like Mike Russo. He's got a big job, a day job that keeps him 18 hours a day busy. But fortunately, that leaves another 6 hours for him to invest and appreciate his contributions, and so does Bob. He's got a few other things to do in his day job too. So I appreciate that, and thank you, Dr. John Mir, for giving us this opportunity. And it's been certainly great working with CCC. So I don't want to sound like an Oscar thank you, but it's very important. It's very important I do that. And thanks to our sponsors, Dr. Bruce Kramer from NSF and NIST as well. So.
Okay, so we're not really pulling the curtain. We provided the opportunity for some people to sneak out, and continue the dialogue.
We open the floor to questions if you have any questions.